Okay, good morning. Lesson 12.3. Today we're going to add probabilities. Not too bad today. Pretty much common sense. There is a formula, but again, a lot of these things are probabilities. If you just kind of look at it and count out what elements you have, sometimes it's not as hard as you think. So here we go. We're going to look at a Venn diagram again. Excellent. All right, considering, let's see, the spinner, or consider the spinner shown below. That's divided into 8 equally sized sectors of a circle. So if you look at the spinner on the right, you have an equal chance of landing on any number from 1 to 8. The spinner is spun once. In this experiment, we will let A be the event of it landing on an even, and B be the event of it landing on a prime number. All right, so what we're going to do is we're going to set up a Venn diagram. And for those of you that don't remember, a Venn diagram has usually 2 circles that intersect. There's a big box around it. Reason why you have a box around it is because the box represents the sample set, all your possible options. So now you'll have some that fall into this option, some that fall into this option, some that fall into both. But you also might have a case where something does not fall in there at all. Okay, and that's what's going to happen here. You've got the set of evens, you've got the set of primes. Okay, so you have to know, I know you guys know all evens, but primes is a little tricky. So let's kind of talk about set A, right? Set A would be you spin the spinner and you get an even. So I want you to list all the evens here. All the evens, 2, 4, 6, and 8. 2, 4, 6, 8. Okay, and then set B is prime numbers. Now, prime numbers, if you guys recall, that's where the only factors are 1 and itself. So something like 2 is a prime number because 2 times 1 is 2. Okay, that's the only way to make it. Something like 3. 3 is also prime. 3 times 1 is 3. There's no other way to make it through multiplication. Something like 4, though, you can make with 4 times 1 or 2 times 2. So that is not a prime number. That's a composite. So here we go. Let's list all the primes. So I gave you the first 2. You have 2, you have 3. Only one way to multiply to a 5. Only one way to multiply to a 7. So 2, 3, 5, and 7. Quick question. The number 1, is 1 prime or is it not? And actually 1 is not prime. It's like kind of like the odd man out. So 1 is not prime. All right, so we listed everything. Now what we want to do is fill in our Venn diagram. All right, so this here, this section without that middle piece represents just the evens. This right side without that middle piece represents the primes. This piece here represents anything that happens to be even and prime. So anything that's in both sets. So what's in both sets? The number 2. So the number 2 is the only element that's going to appear in both. Now what's in set A that's not in the middle? We have 4, we have 6, we have 8. And for set B, we have a 2, but that's already taken up here. We have a 3, we have a 5, we have a 7. Now, remember, the box around it includes all of your options. There's one number on the spinner that doesn't appear in either of those, and that's the number 1. And that you're just going to put somewhere inside the rectangle, but not inside the circles. Okay? So now we go into 2 separate definitions, the union and the intersection. Okay, so for 2 sets, A and B, you have something called their union, which is commonly known when you see the word or. And then you have the intersection, which is commonly given in words by and. Okay, now, if you're looking at your Venn diagram, right, the union is everything put together. So everything in both circles, you put all together. So when it says union, it's like the union comes together. Put all together. Okay, and the word or is what we think, right? And now the word or, you sometimes have a symbol that looks kind of like a U. Okay, so your element X is in either A or B. That's what it means. The number that you're looking for is in one of these places, okay? Now, when you deal with the intersection is that little piece in the middle, okay? That has to be in both. Your X is in both A and B, right? So it's that little tiny piece. That symbol for and looks like an N, okay? And that's what's in both, what they have in common. Okay? All right, so what we're going to do is example 2, we're going to use this data from example 1, and we're going to answer some questions. The first thing they want us to do is find the union. All right, so the union here says put it all together, whatever's in the circle. Okay, so what elements are found everywhere? And usually you try to put it in number order because it's easier to follow. So we have a 2, right? We have a 3, we have a 4, a 5, a 6, a 7, and an 8. Right? That's everything in the circle. Remember, 1 was outside the circle, so he doesn't count. The intersection is the little itty bitty piece in the middle. That's what they both have. They both have 2 in their set. So there's only one element in the intersection. All right. So from example 2, this is really important. So we want to know, why is the equation, right, the number that's in A or B, okay, which is here, not equal to the number in A and the number in B. All right, well, here's the thing, right? The number in A, right, the number of elements in A up here was 4. The number in B was also 4. So they're saying, why is the equation, the number of A and the number of B, not true? Well, 4 plus 4 would give me 8. But there's no 8 elements in here. Okay, there happens to be 7. All right, so there is 7 elements in A or B. So that's not true. It's not equal to adding the probabilities. You know why? Because you are double counting 2. You're counting 2 in here and 2 in here. It's like double counted, right? So the 2 appears in set A, the 2 appears in set B. So when you are adding probabilities, you have to make sure, right? You take the number in set A, right? And you add it to the number in set B. But anything you double count, you have to subtract out. There was one element that we double counted. That was the number 2. So 4 plus 4 is 8. 8 minus 1 is 7. And that makes sense. So you don't want to double count. That's the problem. Okay, that's the issue with adding probabilities. So just be really careful. It will lead up to a formula in about 2 minutes. All right, so next page. All right, so we have what's called a two-way frequency chart. I just want to make sure we're kind of in there. Okay, so here we go. Two-way frequency charts give us a great example how sets can combine. Remember, when you combine, put everything together, that's the union. And overlap. Overlap is your intersection, that little piece. Okay, so what we have is a very small high school. 52 seniors. They asked about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them in one of 4 events. All right, so you could either be male or female. You could be going to college or not going to college. So it's 2 separate pieces of information, and then we're going to try to figure out putting it together. So as far as going to college, 16 male are, 13 female are. So 29 are going to college, okay? Not going to college, 14 males, 9 females. That adds up to 23, okay? So 29 kids are going to college, 23 are not. So 52 total this way. If we look at the gender, right, we had 16 males going to college, 14 males not going to college. So the number of males we surveyed, 16 and 14, is 30. All right, with females, 13 are going to college, 9 are not going to college. 13 plus 9 equals 22. So the idea is a two-way frequency chart. When you add up these two numbers and you add up these two numbers, they're going to add up to that same bottom number. Okay, so sometimes they'll give you a chart that's incomplete and you have to fill in the blanks, but it's all based on the fact that they have to add up to 52 this way, 52 this way. All right, so all we're doing is right now we're looking at straight values. We're not doing probabilities yet. We just want to know the number, N, the number of males, females, college, no college, male in college, female or college. All right, so let's talk about this. How many males do we have in our survey? All right, the total number of males is going to be that 30 down here. So the total number of females that we surveyed, look at the female column, 22. All right, the number going to college, that's C. The number going to college, look at the total, is 29. The number not going to college total would be 23. All right, so those are pretty obvious, right? Reading off of the chart. Now we're going to get a little bit, more specific. So males going to college. All right, so going to college, male, that's going to be 16. All right, females and going to college. All right, females and going to college, that's 13. All right, so now they want the number of females or going to college. So now you have to take into consideration, if you look at the females separately and the college goers separately, you are going to have some female college goers, okay, if that makes sense, college goers or going to college. So you have to take out what you're double counting. So we have the number of females, right, like we did before with evens and primes, and then we subtracted out what's in both. So you have the number of females, right? The number of females is 22. And you're going to add to it the number going to college. The number of going to college was 29. But you have to take out the double counting. So you have to take out the females going to college. The females going to college is right here, females in college. You have to take out that 13, which means you get a total of 38 that are either female or going to college. Okay, so this part here, the double counting, is what you have to be careful with. All right, now what we're going to do is we're going to do some probabilities. So part out of whole. All right, let's see. Part B. What is the probability that a person picked at random would be a female who is going to college? All right, so the probability of a female and going to college. All right, part out of whole. All right, how many people are female going to college? Female going to college is 13. Now, the whole represents the whole amount of people that were surveyed. There were 52 people surveyed. So 13 out of 52 is your probability. Okay? The next thing we're going to do is, what is the probability in letter C that a person picked at random would be a female or going to college? All right, so this is where this Roman numeral 7 comes into play. All right, it's the part out of the whole. All right, now it's the probability of female or college. Okay, so the female or going to college. All right, so part over whole. The whole, again, is going to be 52. The part is going to be the female or college. We just figured that out. The number of people that fall into that category is 38 out of 52. All right, again, why can I just not add together the females with the college people? Okay, now the reason that is, we explained it before, is that up here, you can't double count. There are going to be some female college goers. So you're going to have some sort of double counting in there. Okay, because you're counting female and college twice, right? They're getting counted twice. So now there is a general formula, and this is what I was talking about. All right, if they ask you to find the probability of A or B, female or going to college, okay, you're going to take the probability of A, the probability, say they're female, plus the probability of B, which would be the probability they're going to college. And then you have to subtract out the probability of both, the probability of A and B. And that's a standard formula. Now, a lot of times they'll give you A or B. They'll give you the probability of A and the probability of B, and they'll ask you for that part here. So anything is fair game. Okay, just remember, if you want the probability of A or B, you take the probability of A, you add it to the probability of B, and then you subtract out the probability of both happening. Okay, so we're going to actually do that right now. We have a standard 6-sided die is rolled once. So obviously you can get a 1, a 2, a 3, a 4, a 5, or a 6. All right, they want to find the probability that the number rolled was either an even or a multiple of 3. All right, so we're going to call evens A, multiples of 3B. So the best thing you could do is list your elements in each. All right, your elements in A. You're rolling a die, you're looking to get an even. You can get a 2, you can get a 4, or you can get a 6. For set B, a multiple of 3. Well, when you roll a die, you can get either a 3 or you can get a 6. All right, so drawing this in a Venn diagram, remember, you have a big rectangle, right? That represents everything. We're going to have 2 circles that are going to hopefully intersect here. All right, so set A, set B. All right, so let's see. In set A, we have 2, 4, 6. In set B, we have 3 and 6. So it's easier to figure out where you have the overlap. You have a 6 in both sets, so 6 is going to go here. Now, what's in set A that's not in that little piece? You have the 2 and the 4. What's in B? You have a 3. Now, remember, listing the Venn diagram, you also have to add in the elements that are not in here that are still options. So you could roll one of 2 things that do not satisfy any of those. You can roll a 1, right? Because that's not even and it's not a multiple of 3. Or you can multiply a 5. Not multiply. You can roll a 5 because 5's not an even or a multiple of 3. So those are in the set. They're just not in these 2 sets. Okay, subsets. All right, so now let's talk about using the formula. So the probability that you are an even or a multiple of 3. All right, so we're going to do the probability of A plus the probability of B minus the probability of both. Okay, or is the U and is the and. Okay, so the probability that you have an even. All right, first of all, you have the whole is 6 options. Evens, there's 3 of them. Plus the probability of falling in set B. You still have 6 options, of which only 2 are in B. And then you're going to subtract out what they both have. They both have 1 element, which is a 6. So 1 out of 6 is double counted. Tells you the probability of either getting an even or a multiple of 3. Well, let's see. You have 3 plus 2 is 5. Take away 1 is 4 out of 6. Okay, so it's not bad. It'll be like second nature in a second. Just the more you practice, the better you get. All right, so with example 5, right, we were able to do it with a Venn diagram. We can also do it in the formula. Okay, so here, like if you wanted to use just exclusively the Venn diagram, you would just count out all the elements inside the circles. There's 4 elements out of a total of 6, which matches here. With this last example, though, sometimes you can't do a Venn diagram. You have to suck it up and use the formula. All right, and if you look at exercise 6 here, it says insurance companies typically try to sell many different policies to the same customers. So think about that whole commercial with Progressive and Flo, right? She likes to bundle insurance. All right, the same idea here. All right, at one company, 56% of the customers have car insurance. And in that same company, 48% have home insurance policies, so homeowners. And 18% have both. And we're looking to pick a customer at random. We want to find the probability that they have at least one of the policies. So either they have the car insurance or they have homeowners insurance. okay? So this is where we can't use a Venn diagram. We have to use the formula. So I'm going to let the probability of C be car insurance. Let me move that over. The probability you have car insurance is 56%. I'm going to change that to a decimal, 0.56. The probability you have homeowners insurance is 48%, so 0.48. The probability of both is 18%, 0.18. All right, so we got to figure out somebody that has at least one of these policies. So it's the formula. The probability of, in this case, C or H. So remember our formula. It's going to be the probability of the first one plus the probability of the second one minus the probability of both. And that's your formula. All right, so here we go. The probability that we have car insurance, 0.56, plus the probability that I have homeowners, 0.48. Now, if you added them up, they would be above 1. And remember in the beginning of the first lesson of the unit, we said probability is between 0 and 1 inclusive, but not bigger than 1, not less than 0. All right, minus the probability of both, 0.18. And all you do is just, I would say, probably grab your calculator. You add these two, subtract this guy, and you're going to get 0.86. So in the context of this problem, 86% have at least car or homeowners insurance. Okay, so what I noticed the Regents was doing, and again, take it with a grain of salt. I know you're not taking the Regents. They sometimes ask you to explain it in context of the problem. So having that 0.86 is not good enough. Okay, you would have to turn it into saying, well, that 0.86 is really 86%, and what that represents is 86% of the people have at least car or homeowners, okay? All right, so letter B. Now, this is a trick question here. They want to know, find the probability that they have neither of the policies. So these people picked at random. I don't know. What do they have? Maybe boat insurance? All right, so now let's take a look at a smart way to do this, right? Remember, you have the probability of certainly happening, right? Everything is a 1. Okay, so the 1 is covering all of your options. But 86%, okay, or 0.86 represent the people that have at least car or homeowners, okay? So if you take out that 86% by subtracting, so 1 minus 0.86, that's going to tell you how many people are customers of that company that do not have one of those policies. So 1 minus 0.86 is 0.14. So 14% do not have car or homeowners insurance. Okay, so that 0.14 represents the complement, the probability of it having car or homeowners, and you either have it or you don't. So they're going to always add up to 1. So the 14% that don't, when you add it up to the 86% that do, that gives you 100%. So I hope that makes sense. We're going to next week go into a little bit more involved probability. So this is like your basics. I know it's been a while since you've done probability, but these really shouldn't be too far of a stretch. Maybe that two-way frequency chart is something new. But honestly, if you think about it, these are all common sense, things you've learned before. Actually, I think you've done basic probability in elementary school. If you are confused, please reach out. I'll explain it to you. I can hit it in different angles. You just let me know. All right, enjoy your day.